This lesson is 6-1 from your book. This is Matrix, Operations, and Gaussian Elimination. So first I want to start with talking about something that you all should know from Algebra 2. So if I gave you the problem, solve the system of equations, and I gave you two equations with two variables, so x plus y equals 3 and negative 2x plus 3y equals 4, you could solve this using elimination. You remember using elimination. The way that we used elimination was we wanted to multiply an entire equation by some number in order to add it to the other equation in order to eliminate a variable. So for example, in this problem, x plus y equals 3, negative 2x plus 3y equals 4, if I was trying to eliminate that variable x, well then I would need to multiply it by a positive 2 and add it to equation 2. So let's do that now. So if we said equation 2 times equation 1, what would that be? That would be 2x plus 2y equals 6. And then if I said that 2 times equation 1 plus equation 2, if we add this and this together, we would get negative 2x plus 2x, which is just 0, plus 3y plus 2y, which is 5y, and that equals 10. Now, this is my new equation 2 that we're using, so if I wanted to reduce this even more in order to solve for y, I would say equation 2 divided by 5. We're just dividing by 5 on both sides. That would give me y equals 2. Once I have that y equals 2, and we can also pretend this is 1y equals 2. Obviously, we have 1x up here and 1y up there. We can solve for x. So we can plug this y equals 2 back into that original equation. We would get x plus 2 equals 3. Obviously, x then equals 1. Now, we could write this in a matrix. We could use an augmented matrix if we take our coefficients and put that in a matrix and put the numbers next to it. So that would look something like this for where we started. We started with our coefficients 1, 1, dot, 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 3. Negative 2 is our second, 3, and then 4. And this is our augmented matrix of that system of equations. Now what we ended up with was, first we got 1, 1, and 3. That stayed the same, but we were able to eliminate that x, right? And we got 0, and we reduced this down to 1, 2. This is a very important sort of matrix. We'll come back to what that is. The last thing we did was we solved back for that first one, so we were able to reduce this into 1x, 0y is equal to 1, 0x, 1y was equal to 2. So these are very important. This first one here is called Row-Echelon Form. So that's a very important vocabulary you'll need to know for this. Row-Echelon Form. That's when we have ones on our diagonal. That's what that looks like. So every row below has a 1. You don't have any other coefficients down here. This is another way you could look at that. We see we have 1, 1, 1 all on our diagonal. If we had another row, it would have to be zeros. That's the only thing that would be acceptable for row-echelon form. This last one we did, where we have 1s on our diagonal and zeros everywhere else, except for to the right of our augmented matrix, is called reduced row-echelon form. These are long words, so row-echelon form I'll tend to just abbreviate as REF, and reduced row-echelon form I'll tend to abbreviate RREF. Those mean the same thing. So the way we get row-echelon form is by doing something called Gaussian elimination. Elimination, I swear I know how to spell. And the way we get reduced row-echelon form is by doing gauss-jordan elimination. So these are fancy words for stuff that you already know how to do. I'm not actually teaching you how to do anything new. You know that we got this 2 times equation 1, 2 times equation 1 plus equation 2. In order to get this new equation 2, we divided it by 5. That's all just algebra stuff. Now we're just doing it in a matrix. So you're allowed to always solve these sorts of equations using a matrix. We'll talk about why it might be easier in a little while. Let's look at another example. So we're given it says perform the indicated elementary row operations. So elementary row operations are exactly what we just did. We're multiplying equations, adding them to other rows. and then to produce the row-echelon form, REF, of the given system of linear equations. So we're given three equations: x minus y plus 2z equals 6, 2x plus y plus 5z equals negative 9, y minus 2z equals negative 5. So we're just going to put all of that into a matrix. All our coefficients in order, xyz, 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 go on this left side of the dotted line. To the right side of the dotted line, we have whatever we had the number it was equal to. So we have 6, negative 9, and negative 5 on that right side. So that's step one. Just write it all in an augmented matrix. That's what that is called, augmented matrix, if I ask you to give me that. So step 2 is to say row 2 minus 2 times R1. So let's look at that row 1. In order to get rid of this 2, or to make that 2 disappear, we would need to multiply row 1 by 2 and then subtract it from row 2. Or you could think about it as multiplying row 1 by negative 2 and then adding it. It's the same way to think about it. So we get 0, 3, negative 9, and negative 21. But we don't want a 3 as our first leading coefficient there. We want a 1. So all we need to do from there, this goes to step 3, is to divide that row 2 by 3. That will give us a 1 as our leading coefficient. So we get 0, 1, negative 3, and negative 7. Okay, this last one we need to get rid of this 1, right? We want our only 1s to be on the diagonal. So we need to get rid of that and then get that leading coefficient to be a 1. So we can do that by saying row 3 minus row 2. That gives us 0, 0, 1. We actually don't even need to divide by anything because we get it automatically 2. So that would tell us off the bat z equals 2. Then you could solve for the rest of it by plugging it into the other equations or creating that reduced row-echelon form. So this question is very similar. It says solve the system of equations using Gauss-Jordan elimination. There's actually a very simple way to do this on your calculator. So if I'm asking you for reduced row-echelon form using Gauss elimination, I will totally accept you doing it on your calculator. If I ask for the row operations, then I need to see each of those steps. And I will explain how to do that on your calculator in the next video. Let's just walk through this one really quickly. So it says write the augmented matrix. So we're just going to fill all that in, make sure everything is in order. We have 1, negative 1, 1, dot, 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 1. Then we have 2, 1, negative 1, negative 4, negative 1, 2, 3, and 7. So I'm going to suggest that you try to work out these row operations for yourself, and I'll provide the next step for you. But that way you can verify that you know how to do this and that you're comfortable. There's also more than one way to skin a cat, so you can do this different ways and you'll still result with the same answer. You know that from doing elimination, that some chose to get rid of the x variable first, some chose to get rid of the y variable first, so that's fine. So the next step is to apply elementary row operations to attain the row-echelon form, so that's where we have the 1s on the diagonal. So I'm going to let you guys do that, and I will show you what I got as the answer to that. I got 1, negative 1, 1, 1. Then on the second row, 0, 1, negative 1, negative 2, 0, 0, 1, 2. And then we want to reduce it into RREF so that we have 1s on the diagonal, 0 everywhere else. We get 1, 0, 0, negative 1, 0, 1, 0, 0, and 0, 0, 1, 2. So what does that tell us? Well, we wrote this in order of x, y, z. So now we have x equals negative 1. You can see that from that first row. Y equals 0. You can see that from the second row. And z equals 2. Again, I'm going to walk through this problem in the next video on how to do that on your calculator. It's really quick.